Okay, our next part of this is simply just a couple of things to make sure you know what the heck is going on. When we're talking about identifying functions as growth, decay, or neither, and explain why, well, we need to look for our growth rate or our decay rate. Now, A is f of x equals 4 to the x. That's really 1 times 4 to the x. Okay, I like to put that in there because kids don't remember that. But it's not important here because I'm looking at the growth rate of 4. Well, is this growth or decay? Obviously, it's growth because that 4 is bigger than 1. Okay, remember the 4 is the b, the growth rate. So if you look at the second one, it's got a growth rate of a half. If you'll remember, if it's between 0 and 1, it's actually decay. Don't worry about negatives. Negatives should not exist there, and if they do, there's a mistake. You can't have a negative growth or decay rate. That just doesn't exist. You look in letter C, and this is really 1 times 1 to the x. Again, the first one doesn't really matter. The second one does. Here's your growth rate. But we have a problem here. This growth rate equals 1. Well, to be growth, it has to be greater than 1. If it's decay, it has to be between 0 and 1. If it equals 1, it's nothing. So this one is neither. Okay? Now, I asked you to sketch the graph in question 1a, which was f of x equals 4 to the x, or 1 times 4 to the x. That helps you because the 1 is the y-intercept right here. These go by 2's. Okay, you can just plug this right in your calculator or just make a table, because 4 to the first is 4, so after 1, this goes by 2's also, so after 1, it goes up to 4. 4 squared is 16, so after 2, we're all the way up to 16. Go backward, 4 to the negative 1 is negative 1/4. 4 to the negative 2 is really 1/16. So see, this bunches up and gets really close to the x-axis if I keep making dots like this. The overall premise here is that it's close to the x-axis, but it never ever hits it. Okay, so this would be your graph. I hate that we had to do it by 2's, but that's okay. It still worked out. So the domain of any exponential function, growth or decay, you should remember, we talked about it, is always from negative infinity to infinity. Tried to see which infinity symbol looked better. I hate them both. Anyway, laugh like we would in class. Range, that one's easy. That one's the upward. Well, it's never going to hit 0, but it's going to continue to go up to infinity. Obviously, we have an asymptote at the x-axis, which is the equation y equals 0. There can't possibly be any x-intercepts with an asymptote being the x-intercept. The y-intercept, again, is pretty easy on this one. It was really given to us, or you figured it out, 0, 1, because 4 to the 0 is 1. End behavior, this is where you guys are struggling a bit, even from the last unit. If I kind of look at the arrow, I'll label them. We'll call this A, and we'll call this B. I didn't really give myself much room to write here. Believe it or not, I'm going to write it down here. So end behavior is down here, okay? Now, A, you'll notice as x is getting bigger, so as x is approaching positive infinity, it's also going to continue to go up to positive infinity. That's that branch. The B branch, now I have to look to see what the x is doing. Well, the x is obviously going to negative infinity. But what's happening to the y's? They're getting closer and closer to 0. You need to brush up on your end behavior. It's a good time to maybe go look for a video on end behavior on YouTube or Khan Academy. There's plenty of places where you can literally go into your Google bar and just type in end behavior and it will show you how it works. You can go to images, and a lot of worksheets have been posted from other schools, other teachers on how to do end behavior. You'll notice it's the same. But some of you still need the practice with that end behavior, so make sure you do so. Anyway, now my interval of increase, decrease. Well, obviously, this is an increasing function, so I'm going to circle increase. And it's going left to right, so basically we're just dealing with negative infinity to infinity. Okay? So that's the basics of this section. I have some practice here that's right out of the book. Here's the table for it. And then there's a review. This review actually is pretty decent. It's showing review of transformations and roots and things, which we're going to be doing transformations again in this unit. I love number 3, where it wants you to identify extrema, zeros, and intercepts. That takes us way back to first semester. And then the actual lesson of pretty much identification of exponential functions, half-life, and writing functions from a geometric sequence, and then finally just what an exponential versus a linear graph looks like in terms of money. Okay? Hopefully that graph goes down. And that takes care of section 3.2.1. Have a good day, and I will talk to you tomorrow.